Hi, I'm Professor Goins. Welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in college mathematics, you've come to the right spot, so go ahead and click the subscribe button. That said, let's get into the current video. I'm going to talk about the equation of a sphere. Now, first things first, in 3 dimensions, suppose I have a pair of points. Suppose I've got a point over here, and let's label that as, say, ABC. And let's say I've got a point over here, and let's label that as XYZ. What is the distance between those? Okay. Now, the distance formula between points in 3 space is very similar to the distance formula in the plane. And so let me go ahead and give that to you. The distance formula between these 2 points is given by, so again, let's say I label this one as, say, P1, so 0.1, and I'll label this as P2, so 0.2. Then the distance between those is given by the following. The distance from P1 to P2 is, I take the difference of the corresponding components, so x minus a squared plus y minus b squared plus z minus c squared, and that's all under the square root. Now, once again, if I cover up, this portion right here, and you look at just these just to this side of my hand, right? That looks like the distance formula in 2 space. And so what I do is I just add that third component for 3 space. Okay, so this is the distance between 2 points in R3. Now, suppose I wanted to look at the following. Let's plot a point, maybe somewhere up here. And suppose I wanted to look at every single point that is distance 1 unit away. Okay, everything that's 1 unit away. Well, I could have, say, a point certainly, 1 unit away here, and then here, and then here, and then here. And what's going to happen is I generate a sphere. Right? So the sphere in R3 consists of all the points that are equidistant from the center. Therefore, let's say the distance here is r. So let's say this is the point ABC. So let's say the center is the point ABC. And let's say the radius of this is r. Then what do I know? Well, the distance from, and let's say this is the point on the sphere, let's label that as x, y, z. And let's go ahead and fill in the equation right there. So the distance is from the center to a point on the sphere is the same thing as the radius. So the radius is given by the square root of x minus a squared plus y minus b squared plus z minus c squared. Of course, that's all under the square root. And then what I'm going to do is just rewrite this by squaring both sides, and I get the following equation of a sphere. R squared is x minus a squared plus y minus b squared plus z minus c squared. So what this is right here is this is the equation of the sphere with center ABC and radius is r. So notice over here, this is going to be a constant. The number there is actually the square of the radius because we eliminated the square root by squaring both sides. Okay. So what I want to do is let's take a look at an example. And let's say I give you x squared plus y squared plus 6x minus 4y plus z squared is equal to 0. And let's say I want to find the center and radius. Okay, well, looking at that equation and looking at this equation right here, notice that I have the only place where x, y, and z appear are inside of these squared terms, whereas down here in this equation, I've got this x to the first power, y to the first power, I've got a square root of x, I've got a square root of y. So what I need to do is I need to manipulate this expression so that it looks like this one up above. Now, if I were to highlight just the x squared and the 6x term, and I want to combine those somehow to make it look like this, that it tells me what I'm going to have to do is use completing the square. So solution, what I'm going to have to do is I'm going to have to complete the square in whatever variables aren't in the correct form. Now, certainly I have to complete the square in x. I'm also going to have to complete the square in y. And then I've got this z squared, and that's the only z term, so I don't have to do anything with that. Let's go ahead and complete the square on the x terms. I would have x squared plus 6x is equal to x squared plus 6x. Now remember, when we complete the square, I'm going to add and subtract something. It could be the same number that I add and subtract to keep it balanced. And what that consists of, it's the coefficient of x divided by 2 squared, and then I'm going to subtract the same thing. And then to put this into standard form is we factor the first 3 terms. And so come over here, get rid of this stuff. Okay, so that would give me, first of all, of course, let's do this. 6 over 2 is 3, so that's 3 squared, which is 9, so that is x squared plus 6x plus 9 minus 9. Of course, that factors as x plus 3, x plus 3, and then I still have that minus 9. This being a perfect square, I can then write it in the form I was hoping, x plus 3 squared minus 9, so I have that now in standard form. Let's do the same thing with the y terms. So y squared minus 4y is equal to, right, so y squared minus 4y. I'm going to add negative 4 over 2 squared minus the same thing. And then we'll go ahead and factor the first 3 terms. Negative 4 over 2 is negative 2, squared is 4. That means this is y squared minus 4y plus 4 minus 4. And that's going to factor as y minus 2, y minus 2. Minus 4 in the end. And once again, that's a perfect square, giving me y minus 2 squared minus 4. So the x terms are going to get replaced by x plus 3 squared minus 9, and the y terms are going to get replaced by y minus 2 squared minus 4. All right, go ahead and clean. See if I can leave, let's see, what could I try to leave up there? I guess I'd like to leave this side. So what I'm going to do is I'm going to, just for bookkeeping purposes, I'm going to rewrite those terms down here, and then I'm going to erase this side. So x plus 3 squared minus 9, and then y minus 2 squared minus 4. Okay. So then that way I can leave the original problem up there along with the general formula. So let's get this side cleaned up. Okay. Now, the original equation was right here, and when I replace those terms, I'm going to get the following. X plus 3 squared minus 9. So that replaces those 2 x terms. Replace the 2 y terms with the y minus 2 squared minus 4. And then I had that one z term, and it was just z squared, so I can use just z squared is equal to 0. All right, now what I need to do is I need to put this equation in this form, which means all I have on the one side with the variables is just these squared terms, and then the other side is all the constants. So the -9 and the -4 is going to get added to the other side. I've got x plus 3 squared plus y minus 2 squared plus z squared is equal to 13. All right, now from this we should be able to pick off the center and the radius of the sphere. The center, okay, if I look at each one of these terms, the x component is found underneath the square of the x term, and it's after the subtraction, so x minus a. Well, this is x plus 3, but of course plus the same thing as 2 negative, so x plus 3 is the same thing as x minus -3. So what I'm going to do is take the opposite sign of this, -3, opposite sign here is 2, and this is just z squared, which of course is the same thing as z minus 0, so therefore the z component is 0. And the radius, this is probably the most common mistake, is for people to say then the radius is 13, but the radius of course is the square root of 13. So it's the square root of that number on this side. Because remember, this 13, of course, is the same thing as the square root of 13 squared. And this number here is the square of the radius. Okay. All right. Thank you for watching, and please consider subscribing.